Hi, everybody. My name is Fraser Cain. I'm the publisher of Universe Today. As you can see, it says it right there. And this is your weekly space hangout for September 13th, 2012. And we're back from our hiatus over the summer. We all had very busy summer schedules, mostly going to fun conventions and sitting by the river. So maybe that was just me. But I just wanted to let you know that we're still totally committed and we're back and we're going to be putting together lots of great shows for you. So it starts right now. So joining me this week is my good friend and colleague, Jason Major. He blogs sometimes for Universe Today and sometimes for Lights in the Dark. He gives us the good stories and the other ones for his own blog. We've got Nicole Gugliucci, who is Dr. Nicole Gugliucci. Can't forget that, from CosmoQuest, also known as the Noisy Astronomer, and my partner in crime from Astronomy Cast, Dr. Pamela Gay. All right, so this week we've got a bunch of big stories that have broken, and so we're going to be talking about the fact that Dawn has left Vesta, is now on its way to Ceres. The Curiosity rover has been doing a bunch of self-diagnostics and is getting set to do some real science. We're going to talk about this impact that was discovered by amateur astronomers of some object crashing into Jupiter and the results of that. And we're going to talk about the space shuttle moving from the Space Shuttle Endeavor moving from its from the Kennedy Space Center to its final location at the California Science Center in Los Angeles. So we've got a bunch of other stories as well, so we'll kind of get cracking. So first, let's start with you, Dr. Nicole Gugliucci, because you actually have been following the story, which is the spacecraft Dawn has moved from Vesta and is now going to go to its next destination.
Yeah, so Dawn has left the second largest asteroid in our solar system, Vesta. It spent a little over a year exploring the asteroid, taking high-resolution images of the surface, probing, using a gravimetric probe to probe the interior and discover that it has a significant iron core. And it left and is on its way to Ceres now. So Ceres is formerly known as Planet Ceres, but now is a dwarf planet, and was also known as an asteroid Ceres, just to make things more complicated for you. So there's a couple ways that you can actually look at Vesta. So I am going to do a little plug of Asteroid Mappers because it's a CosmoQuest project where. So now that Dawn has actually left Vesta, it's got these tons and tons of images that the scientists are starting to go through. They've already made some significant discoveries of boulders on the surface of these weird complex crater chains. The famous Snowman crater was one that was in the news for a while. So the departure from Vesta was successful, and it's scheduled to arrive at Ceres in February 2015. So basically, we have until 2015 to focus on that Vesta data and see what more we can discover. Things that they're looking for are the cratering evolution on the surface of Vesta, and things that we can learn about the formation and evolution of the solar system from these planetoids that were left over and never really formed into planets.
What's kind of awesome is some of the early discoveries that are being made, and sorry for the bad voice, I'm fighting a head cold. They're already discovering that Vesta, just like many moons, just like our own planet Earth, is what's called differentiated. This means that it has a core, it has different levels that have different compositions, and we're able to see these different layers and the cutouts created by impacts on the surface. So just like driving down the highway, you might see different layers of stratigraphy in the highway cutouts here on the planet Earth. On Vesta, you're able to look at the walls of the craters and see these different layerings. It's also kind of awesome insofar as we're, for one of the first times with an asteroid, seeing these ridges and troughs that are formed from the planet having massive, reshaping occur due to some particularly large impacts in its past.
Well, so what are we going to be looking at? Like, what is expected to be different between what was uncovered at Vesta and what they're going to be finding at Ceres?
Well, Ceres is looking. Oh, go ahead.
Ceres is a little bit bigger, so there'll be fine changes in how we understand the objects based on size, and we're building up a picture from small objects that aren't completely spherical like Vesta up to spherical objects like Ceres and then to the smaller planets. But the more interesting thing is there's certain division lines within our solar system where inside of those lines things have water and ice, outside of those lines they don't. And Ceres and Vesta formed on opposite sides of what's called the water line in the asteroid belt. So there's the potential for different compositions that were in the material from which they formed.
And so, sorry, which one formed on which side?
Ceres formed on the water side and Vesta on the dry side.
And so the goal then is perhaps we're going to find deposits of ice, deposits of, in
well, it's
craters.
not so much deposits, because deposits come from when a comet crashes into them and leaves its material. This is more a matter of during the early solar system, as the sun was blasting outwards, the chemical composition at different points changed based on what was allowed to exist at the different thermal places. So inside you were able to get, inside you had all of the volatiles blasted away, all of the waters, all of the things like dry ice blasted away. Outside of that line, minerals and such were able to form that contained those volatiles.
So what would you say was the biggest surprise of all of the work that Dawn has done at Vesta?
I'm not sure there was any one giant surprise other than the fact that the sucker got basically hit in the butt by a giant object, creating that.
There's these ripples coming from the South Pole that it's amazing that it held together, or at least reconstituted itself some way after that giant impact. It's not. We have seen other things like that in the solar system before, but I think it was pretty spectacular, and no one had seen it yet.
So is there going to be any science getting done between now and Ceres at this point, or is it just time to go quiet and wait for the next encounter?
The data has been taken, but the science from that data still has to be done. It's a lot of work beyond that.
What most people don't realize is the cycle of science. You go to the telescope, you take your data, it then takes you 3 to 4 times longer to process the data than it took you to get it for some telescopes. And then once you have the data, you have to do the scientific analysis on it. And there's reasons that NASA gives people 6 months in most cases to process their data before it goes public. It just takes that long to transfer photons into scientific papers.
All right. Well, this is good. It's a great mission, and I'm really excited to see when it comes to Ceres and see all the differences. So it's going to be the comparisons. I think what are going to be great. Yeah,
and
Nicole?
Ion thrusters, which is awesome. Which, if according to Star Trek, ion thrusters were a sign of highly advanced civilization beyond that of the Star Trek Enterprise, which is just silly. But we have ion thrusters, and that's what makes it possible for it to visit one asteroid, spend some time there, and then kick off and go visit another asteroid, which is pretty cool.
Yeah, the only thing is that it takes a little extra time than people usually used to seeing with chemical rockets and things. It doesn't shoot off; it moves off.
But it's very energy efficient, so it's a way that you can get a lot of movement done over a long period of time. If you're patient, you can go all kinds of places. Right.
In fact, I think Ceres. Dawn's going to get to Ceres in early 2015, so got a couple of years of travel to get there.
Yeah. Okay, well, let's move on. So the next big story that happened this week was amateur astronomers discovered a impact on the surface of Jupiter, and this was quite exciting. So, Pamela, you were following the story a bit.
Well, it's just one of those things that it's crazy how our understanding of the solar system is still changing so radically. Back when Shoemaker-Levy 9 happened in '94, we thought that it was a once-in-many-hundred-year event. Well, earlier this week, Dan Peterson was, he was just looking at Jupiter, and he saw this flash that lasted about 2 seconds and had this moment of, wow, I did. And then, of course, you have the it's the big fish story. How do I get people to believe I just saw a fireball on the side of Jupiter? And so a call went out saying someone in Racine, Wisconsin saw a fireball in Jupiter along the edge. Here's where you should look. Was anyone videotaping it at the time? And one of the common practices that we've talked about in our virtual star party and other things is amateur astronomers will use high-speed imagers, webcams, different basically video devices to take image after image after image of Jupiter and then combine the best. Well, you can see in Jason's screen this little white blob that it just turned out that George Hull down in Texas, he was several hours south driving from Peter, observing Jupiter, and he caught the 2-second flash in one of his frames from his video. It's just one of those amazing, wow, we actually saw that. Enough people were looking at the right place at the right time. And the odd thing is, I haven't been able to find any evidence of a scar the next day. So whatever this was... I have
seen a couple. It's very faint, though.
Okay.
Yeah. Yeah, there were some faint scar images that came out the day after. But what happened, right, was that you had that explosion right towards the limb of Jupiter, and then it rotated away from view, and so we had no view for about 9 hours while Jupiter was rotating, and then it wasn't until at that point then that we got a chance to look at Jupiter again. So it was quite funny. So instead of like somebody seeing something and everybody piling on, it was somebody saying, I think I just saw something, but we can't confirm it for another 9 hours, and so everybody else geared up and got ready. But it definitely wasn't a big bruise. I don't know, Jason, if you have any of the images. It definitely wasn't a big bruise in the same way that Shoemaker-Levy 9 was just...
or any of the more recent impacts that have been observed by amateurs.
But I mean, we're in a really new time now where amateur astronomers are using these, pretty nice telescopes, these DSLR cameras. They're taking video, they're taking non-stop video to produce a really nice high-resolution image. And so the likelihood that someone is actually going to have video footage of the planets of Jupiter is just going up exponentially now, and so chances are a lot more of these events are going to be captured. So it's almost like this is an indication of things to come, that we get to the point.
Yeah, we didn't see that.
No, we didn't see that. That was
and that's a Hubble image.
Yeah, and that was the previous impact, right? No, that doesn't look like a Hubble image.
That was the Shoemaker-Levy 9.
Oh, that was one of the Shoemaker-Levy 9s. Okay, yeah. So we didn't see that. No. But that's what's possible.
And what's amazing with all of the technology updates that you're talking about is it's getting to the point that it's the amateur astronomy community that's actually doing interplanetary meteorology. They're the ones that are noticing new storms forming on Saturn. They're the ones that are noticing bands disappearing on Jupiter. They're the ones that are noticing new dust storms kicking up on Mars. And it's this great dichotomy where the professional astronomers are building bigger and bigger scopes that see fainter and fainter objects but can't safely look at the planets. And so the planets are becoming the domain of the amateur astronomers who are making very meaningful contributions.
Yeah, and I really think the images that are coming out from some of the astronomers, they're mastering this technique of taking long video footage of Jupiter and then stacking the images together to give you this really high, crisp resolution that you would swear was a picture taken from the Hubble Space Telescope. The resolution on these images is so beautiful and so crisp and clear. So you can imagine, we're going to get to a point now where amateur astronomers are just going to, point at, say, Jupiter and just record video all night long, and then the scientists will use that as a treasure trove of science. So yeah, and this broke over on Cloudy Nights, which is a really great forum. I remember somebody on Cloudy Nights said, I think I just saw something hit Jupiter. Can anyone confirm? So I think that was great. Now, there was a cool question, which I think would be kind of interesting. This came on YouTube. So has it been, is it confirmed as an impact? What kind of object probably did it?
At that distance in the solar system, it's more than likely that it was something kind of icy, but it's actually impossible to know because there are rocks that got flung that far out. There's the Trojan asteroids that share the same orbit that Jupiter does, but there's also a lot of, infalling ice from the outer solar system.
Now, is there any possibility that there's like some kind of atmospheric effect, or is it had to be an impact, like a big lightning bolt, right?
Yeah, this was not a big lightning bolt.
Right.
This would be small rock falling from the sky or large ice ball falling from the sky.
Cool. Okay, so Jason, so you've been following the space shuttle Endeavour moving from the Kennedy Space Center to its final location in California. It's actually going to be coming. Are you in Houston right now? Or are you in?
No, I'm actually in Providence, Rhode Island.
You're okay because you were in Texas,
I was
right?
in Dallas.
You're in Dallas, right? Because I know they were bringing the space shuttle into Texas, and they were going to low fly over the city there before moving. But this is what they've done every time, right? They take the shuttle before they decommission it. They fly it over like New York City or Washington, and this time it's Los Angeles.
Endeavour is going to take some low flying routes over several cities during its 3-day trip from the Cape over to Los Angeles. Where it's going to permanent residence over the California Science Center.
And so when is this all expected to happen?
Well, the shuttle carrying aircraft arrived yesterday, and I believe it's going to take off carrying Endeavour on Monday. So that's the 17th.
And with these, it's always weather willing.
Always weather willing, right?
Yeah,
and so people in Los Angeles are going to get this amazing treat when the space shuttle is going to fly on the back of its carrying aircraft, like what, below 1,000 feet, and it's just going to
1,500 feet. It's going to be doing these low flyovers, and let me see here. I think I've actually got an image for those who haven't seen one. Of course, this is probably taken from one of the T-38s, but still, So Endeavour is going to be mounted atop the SCA and basically given a tour of various cities from the Space Coast. I believe it's also going to fly over New Orleans. It's going to have a stopover in Houston. And then it'll also have a stopover at Edwards Air Force Base in California as well before it finally arrives over at LAX.
And then they've got a couple of weeks of detaching and processing, and I think this is the craziest part, they're going to drive the space shuttle on the highway about 12 kilometers. They had to dismantle huge chunks of the highway to make this work.
I've actually got let me see if I can pull this up here too. I've got a route that shows the 12-mile route that it's going to take through the streets of Inglewood and Los Angeles. Whoops, I always do that there. So, it's going to come here to LAX and then all the way up the little purple route through Inglewood, north, and then over to the California Science Center. So that's going to be quite a treat for anybody in the Los Angeles area well, let's see. It's going to land on the 20th. So as far as when it arrives over at the Science Center, it'll arrive on October 13th.
Right. And so this is, and I know that actually on Google Plus they've set up a big event to take pictures of the space shuttle as it's moving along the highway. So we'll try and promote that, and you can keep, so if you get out there and take a picture of it moving past some neighborhood or down the highway near you, then just contribute your pictures, and you build this beautiful, I think, collection of really great images of the space shuttle moving to its final location. Now, one thing that's really interesting this time around is with the other shuttles, I think they've been put horizontally in their various locations, but in the California Science Center, they're actually going to rebuild it with the solid rocket boosters, with the fuel tank. They're going to mount it vertically to see the full majesty of the space shuttle in its final location. So I cannot wait to see what this is going to be. This is going to look.
And that will be at the Samuel Oshin Space Shuttle Endeavour Display Pavilion.
Yeah.
And the thing that I love about this is over the past, well, since 1981, there have been a number of times that we've flown space shuttles all the way across the United States to get them from landing at Edwards back to Kennedy for takeoff. And they've never done flyovers. It's just been sort of like, get the business done, get it across the United States. Well, in this final journey. They're taking the time out to go to significant locations. They're spending time landing in Houston. They're doing a flyover of White Sands, which was one of the alternative landing sites for the space shuttle. This is a mission that they're doing everything they can to say goodbye in a respectable manner to something that was near and dear to people all over the U.S.
So Thad, our good friend Thad Sabo, one of the members of the Virtual Star Party, is posting on Google Plus that they can't take it on the highway because of the overpasses, right? It's just too tall. But they're actually going to have to cut down about 400 old-growth trees to make enough room for the route to make that journey. So that's, I know there's been a bit of an outcry at the damage they're having to do to the road and to the, to the trees and to make this journey. So,
yeah, I knew that they were taking out like posts and stuff.
Posts and trees and yeah. So, but yeah, no, it's going to be fantastic. So, who has ever seen a space shuttle up close? Anybody? You have, Jason, and Pamela, you have, right?
Well, it depends on definition of close.
You saw one launch.
I've seen one launch. I've gotten to the fence outside of the launch pad where they let journalists get to. But there's some of the space tweeps out there who've gotten to all but touch it. Nicole and I have a friend who helped walk one of the space shuttles out, and she was one of the people carrying the flag, and she was unfortunately too short to stand up and touch the shuttle's tiles, but she got to touch the landing gear.
And I don't know if Enterprise counts, but I have been up close with that one at Udvar-Hazy before it moved on to Intrepid.
Yeah, and I've been up close to the Pathfinder, but I don't think the Pathfinder counts.
Is that the one that's at the Kennedy Space Center that's in the...
Kennedy had been at Marshall. I've lost track of, in the grand shuffling of space shuttles, I've lost track of where it landed.
Well, we'll do a road trip, everybody. When it's finally at the California Science Center, we'll do a road trip and we'll all hang out and see it, because it's going to be fantastic. I can't wait.
Last year, I had a chance to do a tour of the VAB over at Kennedy Space Center before they were doing the public tours, and Discovery was tucked into one of the side wings there, still undergoing some decommissioning process. So we got a chance to get up as probably about 50 feet away from it.
I saw the pictures and I hated you all.
I just have to point out what he just said. The Discovery, a giant spaceship, was tucked into one of the side bays of the VAB, which is a building built to assemble the Saturn Vs.
Yeah, the VAB is a mind-bendingly large building. I've been there once, and your mind can't wrap itself around what it's looking at. It's just too large.
It's a cathedral to space exploration. I mean, you walk in there and it's been overused, but awesome is the only word that really pertains to it.
Yeah, the letters on the building are taller than, I forget what it is. The flag is bigger than
the flag is the width
buildings.
of a school bus for each stripy bit.
For each stripy bit, that's right. And that's right. The stars on the flag are taller than a person. That's right.
Yeah.
It's crazy. Yeah. What an amazing building. Okay, so one last story then, sort of from the main group, which is, and so Jason, if you can pull up some images. The NASA's Curiosity rover has been doing a whole bunch of self-diagnostics this week. And I'm not going to go too much into detail because I just did an hour-long discussion of this with Emily Lakdawala from the Planetary Society. And so someone maybe can put a link into the comments. But, an hour-long discussion, we took tons of questions, and Emily, as always, is a walking, talking encyclopedia of planetary exploration. But there's a few pictures that have come out which were great. There was two. I don't know, Jason, if you have these. One is the image that Curiosity took of itself. It took a self-portrait from one of its Hazcams.
I've actually got a shot.
Yeah, and that was really great. And so this image was dropped onto the NASA servers, and the folks at Unmanned Spaceflight were all over that right away, and they were able to sort of tilt it and make the image a little more sort of handle the resolution. So this is the raw image, right? That came out.
I actually took the raw image, which was a lot more faded, and boosted up the curves so that way you can really make
Yeah, and then the other image, Jason, if you can prep it, is the one of its belly, the image of the belly, but the one that was stitched that shows the entire underside of the rover.
Oh,
And
right.
Yeah, so
and what's
leave this one and see if you can, or if you can dig up that other one. Right.
And one of the
So
things that's important to note about this image is the dust cover was still over the camera, so this doesn't represent the best
yeah,
imaging that can be done. It's just really awesome.
but the thing that's really interesting, so if you could see this image, and unfortunately my mouse doesn't work here, right? So you can see all of the different instruments that are on this mast cam. And so it's great. Like I said, highly recommend if you check out this other hangout that we did with Emily. She goes into tremendous detail. Every one of these instruments, what they do, how they work. It was a real treat to hear. And then the other image that Curiosity took was of its underside. So it actually, I don't know how, I can't imagine what it did, but I guess it had to sort of look down, with its mast cam at itself and capture these images. And you can see sort of the images of its. Do you have that one, Jason?
Yeah, I got it right here.
Well, it's important to realize that this sucker is completely covered in cameras. So its head is covered in cameras. Each of its wheels has cameras.
Yeah.
Its arm has cameras, and so this is one image-taking monster.
Yeah, and so you can see here, this is actually a composite image. So the spacecraft took a bunch of images of itself, and then I think this image was posted from unmanned spaceflight. So there's a couple of people at unmanned spaceflight who stitched it together. And if you're looking for a great discussion forum where they really sort of stay on top of all of the latest space news, I highly recommend that. But this is the image they put together, and so you can see. So stop right there, Jason, for a second. So you can see there on the wheel of the rover, you can see those holes there. So those are actually Morse code. They spell out JPL, and so what happens is, as the spacecraft is rolling on the surface of Mars, they can look at those little dots and dashes, and they can count how many wheel turns have happened for this last piece of the journey. So there you go. You can see some of the images carved into the Martian soil. So it's a pretty funny thing the way they do that. Sorry. So someone was mentioning it was the Molly is what took the underside images, not the mast cam. So it's got
the Mars hand lens images.
Yeah, so it's got sort of two big camera systems that it's got on board. And one of the most amazing things about this version with this spacecraft is they actually sent a true color, it's like a 2 megapixel camera to Mars. And so up until now, all of the images that we've been getting back are always black and white, because they're just done with a black and white CCD, and then it's used as different filter wheels to capture different resolutions or different wavelengths. But in this case, the spacecraft actually has a full color camera, 2 megapixel camera, with a focusing system that can go with like microscopic close-ups or all the way out to infinity. And so we're seeing these images in just true color, which I can tell you as a person who publishes space news and these images all the time, is that's people really want to know what this would look like if it was in real color. What would our eyes really see? But now the vast majority of the images that we're seeing coming back from Curiosity are these true color images, and it's just gorgeous. So I'm so excited to see the pictures that are coming back. Oh, that's great. Yeah, so this is...
That's its X-ray spectrometer.
And there's actually, so like I said, with the hangout that we did with Emily, there's actually some animations. You can see some of these parts, these flaps opening up and closing in different instruments and different specimen bays being opened up and closed. And you can actually see how the rover is going to be gathering some of the samples, the rocks, different sizes, and it's going to be sort of putting them into these different specimen collection things. I actually asked a question to one of the rover team, does the rover poop? Which, because this was a question that we actually got in a hangout with me and Emily last time, and we actually had no idea. And it's because you think about it, right? It's going along and it's scooping up specimens and it's then gathering them, and then what does it do with these specimens when it's done with them? Does it drop them out behind it? Does it scoop them back out? So the description is that it sort of regurgitates like an owl. It takes these specimens and then it can dump them back out. But it's actually got some specimen cups that it's got that it can actually reuse, and so for really pristine samples it can use absolutely fresh versions of these,
Say, fill up the
but then
cup.
later on it can reuse them. What was that,
There's
Jason?
so many things we shouldn't be saying, and that's one of them, Jason.
Oh.
So yeah, so it's what a fantastic mission, and we will be sending regular updates. So Curiosity has really just been doing this self-diagnostic, but there's a few more. I think there's a few more diagnostics left to do. The next thing that it's going to do is it's going to be doing a test of one of its arms, its drilling arm. So it's going to find a nice flat rock. It's going to take that drilling arm and it's going to put it down on that flat rock, and it's going to push against it to make sure that the gravity on Mars, they calculate everything properly so that it's not going to be pushing too hard, pushing too soft, and it's able to sort of do proper grinding samples for the rocks that it hits. And then at that point, it's time to get to the real science, and it's going to start to actually move to its first destination and start to, examine some of the rock layers. So we're just before the science. But what's amazing is we're 37, 38 days now, which is really surprising.
The reason this mission is taking the time to check itself out like this is it's a long-term mission, whereas the Mars rovers, we only thought were going to last 90 Martian days, 90 sols. And when you have that short a period of time, you cram in as much as you can, and you sometimes take risks. If you're planning to settle for a long term, you do everything slow and careful and make sure that you don't take risks until you're reaching the end of warranty.
Yeah, and so in this case, right, this rover is equipped with a radioactive thermal generator, so it's it's not dependent on solar panels for its energy. It's got this decaying thermal heat source inside of it, and so it can go for years and years and years. I mean, think about the Voyager spacecraft. They're at 35 years and still sending data back. So I don't think you're going to get 35 years. Emily and I talked about this yesterday. It's probably going to be a lot of the motor components, the wheels, things like that are going to start to go before the fuel source runs down. But it's this rover is built tough, and it's going to last a long time.
And I just love how
the image of the calibration target that came in a couple of days ago, showing the color, showing the ability, the resolution ability of the camera that's on board there, that Molly camera. I mean, this thing is sharp, and we're going to see some really, really nice stuff coming in from it.
Yeah, now you can't see in this image, I don't know if people can see it who are watching, but you can see the sort of this, where Jason's thing is pointed, that's the number of lines per millimeter, and so you can see there's like 1 line per millimeter, but if you go all the way down to the left there, it goes down to, I think, 10 lines per millimeter, and you can still, in the original image, you can actually still make this out. So the resolution is unbelievable in this new camera. And then this is a, you see that coin there, that was a coin. It actually says 1907, I think.
1909.
1909, right, 1909. So the goal was that the spacecraft was supposed to be on Mars in 2009, and so that was the coin that they had built into the system. But then the flight got delayed, and so it's actually the wrong date, because here we are in 2012. So
right. And I guess that would be Curiosity's makeup kit right there.
Yeah. So those are to sample or to test different colors and make sure that the cameras, their color sample, I forget the name of them, but. Yeah.
What's amazing is how dusty everything already is.
Already, yeah. This is going to get worse. It should be equipped maybe on the end of its mass cam with a little brush that it can sweep off stuff, but that doesn't.
That's what
one of the other.
for.
I think just yesterday, yesterday they announced that Curiosity had detected traces of chlorine and was it chlorine and methane? Oh no, I'm trying to see. One of the tools there had picked up something, and it was traces from the the first traces that they're picking up from the Martian atmosphere. And if you'll bear with me, I'll find out what they actually are. It was let's see. I say bear with me because I had written a quick post about it. Chlorine and sulfur. So that was some of the first little bits and pieces it picked up from one of its calibration equipment.
So as always, now I think we've got a few more stories. Sorry, Jason. We've got a few more stories that we'll get to, but I want to let people know that they can ask their questions if they want about any of the stories we've talked about today, or really about anything that's going on in space and astronomy. So you can either ask your question on Twitter if you're watching this embedded somewhere with the hashtag #SpaceHangout. You can, which I'm sure that's a surprise to Pamela that I was going to use that hashtag. Right. So you can post your question on Google Plus if you're watching this on the Google Plus page. You can, if you're watching this on the event itself, you can post a question there. Although I'm not able to track those as well. And if you have any questions, you can also post on YouTube. So we've got the video on YouTube, and you can post any questions you want. So I was going to get a couple of questions. One, this comes from Jeff Borst. So does anyone know how much damage the RTG, the radioactive thermal generator, took in the landing?
It didn't.
It didn't take any. No. So the only damage I think so far that's been detected was there was a wind sensor that got some dust kicked into it as part of the landing, and that they're still not sure what the damage is.
It's a rugged little. It's an SUV. And just like you can drop Hummers out of helicopters and they still work on landing once you tip them over on the right side, that same sort of, let's just drop this thing from the sky, rigidity was built into this little rover.
Yeah. So Michael Jobin says, this is back to the Vesta comment. So on Vesta, those equatorial ridge features look like a big rock was rolling and not an impact on the bottom. But I mean, these impact features are gigantic. So I mean, this was something really big, nearly tore Vesta apart.
It may not necessarily be an impact, but something happened overall structurally to the asteroid to make that happen. It wasn't. There are other things that look like rocks have rolled through and left tracks, but not necessarily these cracks.
So is the thought that there was like a really big impact back in the day?
Yeah,
that's one hypothesis. Yeah,
there's folks modeling it. In 2 weeks is the European Planetary Science Conference, and that's the meeting where people typically hold on to the results if they're near releasing and give them there. So
now, Pamela,
stay tuned for 2 weeks.
That Vesta had or has a molten interior still? Or at one point, because I know that they were tossing that around too.
Well, it's small enough, and its composition is such that the sucker's solid at this point. Mm-hmm. But the thing that they're looking at is, could it have still been in the process of cooling off and still have been somewhat liquid when it got hit? Could the hit have released so much energy that it partially melted the surface? There's definitely what's called a certain amount of plasticity in the way they're looking at this. So if you can imagine, some things when you squish them, they just break. Some things when you squish them, they wrinkle up. Vesta, when it got squished, by whatever manner it got squished, it wrinkled up. And so they're trying to figure out, how do you correctly model this?
Okay, so there's a question that came earlier on, so I'll go with that as well. This comes from Clay Cavanis. I wonder how much having Jupiter and the other gas giants as big gravity wells helped life evolve on Earth. Is there some kind of effect? How much? Pamela, I know there's actually a bit of a controversy about this, right? Did Jupiter help us or hurt us?
So the fact that something killed off the dinosaurs was probably evil. So the question is, do we need something like Jupiter to protect us from having impacts that are too frequent and thus would have prevented humans from also evolving as far as we did? Or do we not want something like that? Depending on whose models you look at, it's either extremely useful that you have Jupiter out there helping to protect us, of absolutely no effect because it doesn't eat enough stuff, or it's actually dangerous because its gravity well is helping to fling things towards the inner solar system. So I think this one falls into the category of ask a theorist and you'll get a different answer depending on what they ate for breakfast. Stay tuned. As we get more data, our ability to understand this gets better.
So Jupiter is probably helpful or probably harmful.
Friend or foe?
It depends which end of the impact you're on.
So Trevor Soar Videos asks, with the VAB, the Vehicle Assembly Building, can you actually notice the curvature of the Earth from inside the building if it's that large? It's not that it's wide and long; it's that it's tall. It's just this, and it's again, it's not like it's a super tall building. It's just that it's a super tall building that's super wide. So it's like you take a, I don't know,
and the center of it has
you take a soccer stadium and then make it 500 feet tall.
Well, it's sort of like you never realize how big an aircraft carrier is until you see one in a harbor, in which case you're like, oh wow, that is a city on a boat.
Yeah.
It's just this building that it's take every airplane hangar you've ever seen at an airport and stack them like Legos to allow a Saturn V to be assembled inside. And it can handle that. It does. I've heard it has its own weather inside, because depending on temperature and humidity, you'll get rain.
It makes the "Are we there yet?" question when driving to Kennedy Space Center really amusing, because you're like, oh, there's the building, we must be almost there, and you keep driving.
Oh yeah, it dominates the landscape for miles. It's the only human-built structure you can see for miles. It's really quite the thing.
If you check out,
everyone's mouth opened up. You have a bus full of people. You've got 30, 40 people walk in, and everybody just stops, and the heads just go up.
Yep.
And that's before we even reach the center area where it's clear to the roof.
If you are in any way a space nerd, then you must make a journey to the Kennedy Space Center and see both the Kennedy Space Center sort of exhibits, and if you can somehow get closer access to NASA itself, pull whatever strings you need, get as close as you can to the Vehicle Assembly Building and all that good stuff.
And there's a chance Fraser and I will be getting people to go do this in December in association with the World is Ending cruise.
Oh, that's right. Yeah. So Pamela and I are going to be cruising on a boat in the Eastern Caribbean from like mid-December till around Christmas-ish, and we're going to be standing on Mayan ruins on December 21st, 2012, and celebrating the fact that the world is not going to end. So, in fact, apparently there's going to be another cruise ship that's going to be going there, but they think the world is going to end. So we might run into the apocalyptics.
So this is a historic image I just popped up showing the VAB opened up to allow a Saturn V rocket out, and the fact that it still has space above where the rocket launch pad popped out is kind of awe.
Yeah. Okay, so next question then is how radioactive? This comes from Foramar. How radioactive is Curiosity? Would its nuclear engine be dangerous to a human if they stood right beside it? So it's important to say, and this is what Emily will sort of beats me up every week every time we talk about this. It is not a nuclear reactor. It is a radioactive thermal generator. It is a pile of radioactive material that is decaying and hot, but is not like
and
energy through nuclear.
And it's very well shielded. So basically you have shielded box with radioactive materials inside that as they decay generate heat. The heat is turned into the energy that the rover uses. Many university labs have more radioactive materials than this little rover does.
But if you stood beside the rover, would it be dangerous to you? I don't know.
No, not at all.
Not at all.
With or without shielding?
No. The sucker already is shielded. I mean, that's the thing to remember is like Emily has stood next to this sucker put together.
But if it wasn't shielded, it
you wouldn't want to be there. But it's not that bad.
Yeah.
That's interesting. Okay, cool.
I've played with radioactive materials in the physics lab before.
Yeah, so have I.
Smartly or not.
Well, don't they every now and then I've heard stories about where they'll bring like a Geiger counter into a chemistry lab or a physics lab, and they'll go through and they'll test all of the stuff. And like, oh, that's radioactive. That's radioactive. And
that's actually a real problem. There
Yeah.
was a case several years ago of, I forget which airport it was, realized that there was radiation, and they started tracking it down, and they tracked it down to the shoes of an academic, tracked it back to a lab, discovered a lab that had had a fairly serious radioactive materials contamination issue. And there was a fully assembled astronomical instrument in the lab that had had the spill, and they had to essentially condemn the instrument because it was radioactive.
Yeah.
So this is a real problem. Many of the places I've worked have randomly discovered, oh, we need to get hazmat in. That's radioactive.
12301231234 asks the question on YouTube: is the VAB tall enough to allow you to base jump from inside? And if yes, how can I set that up?
Oh God.
I would assume yes.
Do it. Let's do it.
Get up to the top of the VAB and let go, and had a parachute on you. I believe you could deploy that parachute and float down. So
and
yes.
when you landed, you will be in the NASA brig so quickly.
Yeah.
Can we set this up though, with
how you
security
could set
clearance?
this up?
Pamela, please.
I don't know. NASA, it's a publicity stunt. NASA might do that. Give them a call.
Well, so the VAB is actually going to be getting used by SpaceX. So this might be a SpaceX question as much as a NASA.
But NASA's open to all kinds of interesting. If it gives them publicity and shows how awesome some of these buildings are, they might really want to do it. So yeah, absolutely, give them a call. Give them your pitch. Show them that it's safe, and see if they'll let you do it. And tell me so that we can report on it, and we'll cover it. So
Teach me how to do it too.
Yeah.
Pamela's like, no.
Yeah.
I'm paying you now. Don't die.
Exactly.
I'm serious. I think they would almost be interested if you propose that to them.
Yeah, I totally disagree there.
You disagree? There's no way on earth they would want to get the publicity of somebody doing a really cool Red Bull to the extreme jumping into VAB.
I think this falls into the category of such an insurance risk. I mean, if you think about it, they didn't even show that many videos of the astronaut ziplining and practicing emergency escapes off of the space shuttle because that's the type of thing that if you screw up, you die. And so if there's a reluctancy to share videos of people ziplining off the space shuttle as part of their jobs, I'm not sure they're going to let civilians and non-governmental contractors base jump off of a building.
You're such a pessimist. We're totally setting this up, Pamela. I'll talk to Red Bull right now. Okay.
All right. I hate to cut in. If you guys want to see what the if you want to do a little tour of the VAB, I have a video here that I took from inside the VAB, giving you a look around. So if you want, I can switch over and I can run that. It's only a couple minutes.
Is it long?
Let's post it in the comments.
Okay.
Okay, yeah, that sounds good.
Sure, we'll do.
Okay, so last question, which comes from Stefan De Decker. So the New Horizons team is using Hubble to look for moons and rings around Pluto. Are they looking at infrared and sub-millimeter wavelengths as well?
Sorry, losing my voice. Yes, they are using Hubble. Hubble works in a variety of different wavelengths. So infrared is very useful for looking at these things.
It's almost necessary, right?
Yeah, and one of the interesting things is they're actually not using Hubble to try and discover new Kuiper belt objects. They're using telescopes like Subaru, Keck, the California, France, Hawaii telescope, and they're looking in optical wavelengths for those.
Okay, cool. Well, so one last thing then, which this comes from Carl Frank, who has been sort of reaching out to me on email and actually posted a mention this about last week. And so Carl Frank is looking to change Columbus Day to Exploration Day, which I think is kind of a neat idea. And there's a story on Wired about this and some other places. So instead of it being specifically Columbus Day, to actually make it the more generic just exploration, and then it'd be more inclusive, right? So you could include Neil Armstrong and spacecraft and rovers and other kinds of exploration. So I personally think it's a great idea, but then as a Canadian, I have no control over what Americans do. But there is a...
we need a change.org petition.
Well, no, he's got a petition that's going, and he's got a few weeks, I think, left. He's got till the end of September to pitch that. So if you go to explorationdayusa.org, you can sign the petition and help push for Columbus Day to get turned into Exploration Day.
Is this like yay exploration, boo exploitation? Is that
Yes.
kind of
Yeah, I mean, just it's the spirit of exploration, right? Like celebrate the spirit of exploration.
because Columbus has baggage.
Absolutely
Yeah.
has baggage. Yeah.
Cool.
Yeah. So I think it's a fantastic idea, and I
I'm
posted on
excited.
Google Plus, and I know Carl would like me to do a story on Universe Today, which I may do shortly. So, but here I'm helping out right here. So. With my massive influence. Okay, well, cool. So thank you, all of you who joined us this week for the Weekly Space Hangout. Where can people find out more? Jason.
You can find out more about me on, you can follow me on Twitter at JPMajor. You can also read my articles on universetoday.com. And if you want to find out more about a tweet up and a visit to the VAB, you can check out the article I just stuck to the front page of my website, lightsinthedark.com.
Fantastic. Nicole Gugliucci.
Hi, Noisy Astronomer, all over the internet as Noisy Astronomer. Pretty easy to find. And go to CosmoQuest, because we have cool citizen science.
And Dr. Pamela Gay.
I'm Star Strider with a Y all over the internets, and also go to CosmoQuest and Astronomy Cast. Don't forget that.
Which we've started that back up again as well. So we did a live show at DragonCon about how space, mad stacks of money in space, and we've also talked about, what have we talked about already? It's already out of my head. Oh, right.
What do you call space scientists?
Yeah,
Yes.
how we define space scientists. So we've got a whole new season, lots of good shows coming up, and so you can find those at Astronomy Cast. And so, as always, you can find what I'm doing here on Google+, at universetoday.com, in Astronomy Cast, and then the next thing that's coming up is Sunday night, we're going to be doing our virtual star party. And that's where we hook up a bunch of telescopes live onto Google Plus and broadcast the night sky. Whatever's up, we'll get a picture of that. Last week we had Uranus and Neptune for the first time, which was a real treat. Big thanks to Mike Phillips. So thanks to everybody who joined us. Thanks for watching. Thanks for all of my panelists, and we'll see you all next week right here on Google Plus.